All right, what we're going to do in these next couple examples is we're basically going to just try and find everything we can without going to Desmos. And then once we've found everything we possibly can, I'll use Desmos to sketch it in. So this is y equals 4x over x squared plus 1. First thing I notice is that x squared plus 1 in the denominator is what's called the sum of squares. So it's something squared plus 1 can be written as 1 squared, so that's why it's a sum of squares. But anytime you have x squared plus any constant, it can never equal 0. Because when you square a number, it has to become positive. The only number that doesn't become positive when you square it is 0, and 0 squared plus 1 is 1. So any number you can put in a negative number, say you put negative 2. Negative 2 squared is positive 4, plus 1 is 5. Because it becomes positive and then you add 1 to it, it'll never equal 0. So that denominator can never equal 0, so that means this rational function has no non-permissible values. Okay, and because there's no non-permissible values, there's no discontinuities. So there's no vertical asymptotes and there's no holes, and the domain I know is going to be all real numbers. Okay, now I'm going to keep going and let's talk about the y-intercept. So the y-intercept usually go constant in the numerator divided by the constant in the denominator. But there is no constant in the numerator, so then I assume it's a 0. So then the y-intercept is going to be 0 over 1, which is 0. All right, now the x-intercept. Well, the x-intercept is what makes the numerator equal 0. So the numerator is 4x, so 4 times what number is 0? Well, 4 times 0 is 0. So that means the x-intercept's also 0. Often that's got to be the case. If the y-intercept is 0, then the x-intercept also has to be 0. And last thing to write down, because there's no non-permissible values, the domain is all real numbers. So now we're kind of ready to sketch it, but there's only one point that we have, just 0, 0, which is the x-intercept and the y-intercept. So all we're really doing on this one is graphing this on Desmos, and whatever we see, we're going to sketch. All right, and there I'm just entering it in. There's the graph, and it definitely goes through 0, 0. I'm also going to find the coordinates. That peak is at 1, 2, and that minimum value is at -1, -2. So I might as well put those in, and I'm just going to sketch it as best as I can. So this is kind of a funny case. So when we're sketching these, we're really dependent on asymptotes and holes. And when we don't have asymptotes and holes, there's not a lot we can necessarily find, but that's okay. Okay, so we're very dependent on the graphing calculator is the point of this example, and don't worry about if you have to use Desmos or graphing calculator to get what this looks like.